All right, so we are in Unit 6, Chapter 12. This is Learning Objective 12, which is to describe how surface tension and viscosity are manifestations of intermolecular force. So before we get there, though, we need to kind of define these two prefixes. So intra means inside, and inter means between. So an intramolecular force is a force inside a molecule. So these are the bonds between atoms. All right, so an intermolecular force is the force between molecules. This must have two or more molecules in order for us to have an intermolecular force. So let's look at water, which is one of the most common substances, and look at an interaction between water molecules. Now, water is a polar covalent compound. So it has a dipole, which is the slightly negative, slightly positive poles within the water, so within the molecule. So you have H to O to H. Now, if you remember from the last unit, these electrons are being pulled in this way, as well as these electrons are being pulled in towards the oxygen. But what happens then is that you get this slightly positive pole at each of the hydrogens and a slightly negative pole at the oxygen. So slightly positive here, slightly negative here. That is a dipole. So then we can draw an interaction between two water molecules. Looking at this, I've got three molecules of water that are attached together. Okay, so each line here represents an intramolecular force. We can call this a bond. And this is a bond between oxygen and hydrogen. If you notice, it is within the molecule of water. So if I look at this, here's one molecule of water. Here's two molecules of water. And here's three molecules of water. And the interactions, or the little dots between the molecules, is what we call an intermolecular force. And I abbreviate this as IMF. We'll abbreviate intramolecular forces bond, abbreviate intermolecular forces IMF. Okay, so now getting to how surface tension and viscosity are tied to intermolecular forces. So let's get the definitions for these guys down first. So surface tension is the tendency of a liquid to minimize surface area. So if you're in the shower and you notice that water beads up, that is a form of surface tension. The water molecules are sticking together to minimize their surface area. And then viscosity is the resistance of a liquid to flow. So in viscosity, you've got like honey or syrups or that type of thing. They resist the tendency to flow. So what that means is that they don't flow as fast. So water versus honey is going to be slower at flowing than water. And so let's look and see how these guys are manifestations of intermolecular forces. So again, intermolecular forces I'm abbreviating as IMFs. And then how do we explain this? So intermolecular forces are how molecules stick together to form liquids and solids. So liquids and solids have the most intermolecular forces. Surface tension is caused due to the top of the liquid minimizing the surface area. And this is, again, the water molecules where the molecules are sticking together in order to create that minimized area. And then viscosity is the resistance to flow. So it's really a resistance to break intermolecular forces. And intermolecular forces are how molecules stick together to form liquids and solids. Surface tension is due to molecules sticking together in order to minimize their surface area. And then viscosity is the resistance to flow, or really a resistance to break the intermolecular forces between the molecules. This was learning objective 12, which was to describe how surface tension and viscosity are manifestations of intermolecular forces. Again, intermolecular forces are how the molecules stick together to form solids and liquids, and surface tension is caused by the molecules sticking together and minimizing their surface area. And viscosity is this resistance to flow, which means resistance to break their intermolecular forces.